Today's session, we are going to talk about the performance testing, the benefits of performance testing, the process involved, the types, the metrics, and recommended tools. Performance testing is a testing practice performed in order to determine how a system performs in terms of responsiveness and stability under a particular workload. We have three keywords here: responsiveness, stability, and workload. Responsiveness usually has to do with speed. It has to do with how quickly the application responds while it is performing certain operations. Stability has to do with how consistent or reliable the application is. Workload is the input to the test, the way that we load or stress the systems so that we can see how well it responds and how stable it is. The goal of performance testing is to eliminate performance bottlenecks and to provide stakeholders with information about the software in terms of speed, response time, stability, and scalability. More importantly, performance testing uncovers what needs to be improved before the software is released. Performance testing will determine whether the software meets speed, scalability, and stability requirements and their expected workloads. Mission-critical and safety-critical software should always be performance tested in order to ensure that it can be run for a long period of time without any issues. A 5-minute downtime of Google in August 2013 is estimated to have cost the search giant as much as $500,000 in losses. Page views spiked shortly afterwards. There are four key types of performance testing: load testing, stress testing, endurance soak testing, and spike or peak testing. Load testing checks the application's ability to perform under anticipated user loads. The objective is to identify performance bottlenecks before the software application goes live. Stress testing. This involves testing an application under extreme workloads to see how it handles high traffic or data processing. The objective is to identify the breaking point of an application. Endurance or soak testing. This is done to make sure the software can handle the expected load over a long period of time. Spike or peak testing. This tests the software reaction to sudden large spikes in the load generated by users. Here we have a graphical representation of the types of performance testing. So with load testing, as you can see from the graph, we are checking the system performance while under a specific workload. With endurance testing, we are checking the system performance during a long period of load, hence why it's called endurance test. With stress testing, we are checking the system performance while stressing it until it reaches the breaking point. With peak testing, we are checking the system performance during a sudden peak or surge. What are the common performance problems? First is the long load time. Load time is normally the initial time it takes an application to start. This should generally be kept to a minimum. While some applications are impossible to load in under a minute, load time should be kept under a few seconds if possible. The second type of common problems is the poor response time. Response time is the time it takes from when a user inputs data into an application until the application output a response to that input. The third most common problem is bottlenecking. Bottlenecks are obstructions in a system which degrade overall system performance. This is either due to coding errors or hardware issues. The key to fixing the bottleneck issue is to find the section of code that is causing slowdown and try to fix it there. Bottlenecking is generally fixed by either fixing poor running processes or adding additional hardware. Some common performance bottlenecks are CPU utilization, memory utilization, network utilization, operating system limitation, and disk usage. The performance testing process involves a number of steps. First, identifying the test environment. At this step, we need to examine the software, hardware, and network configuration the performance test is going to be utilizing. The next step is to identify the performance acceptance criteria. This includes goals and constraints for the throughput, response time, and resource allocation. Next, we need to plan and design performance tests. We need to determine how usage is likely to vary amongst end users and identify the key scenarios to test for all possible use cases. It is necessary to simulate a variety of end users, plan performance test data, and outline what metric will be gathered. The next step is to configure the test environment by preparing the test environment before execution and arrange tools and other resources. Next, we need to implement the test design and run the tests. We need to create performance tests and execute them. The final step is to analyze, tune, and retest. We need to consolidate, analyze, and share the test results. In this section, I'm going to highlight the key and basic parameters or metrics that are monitored during the performance testing. Processor usage. This is the amount of time processor spends executing non-idle threads. Memory usage. Amount of physical memory available to process on a computer. Disk time. Amount of time disk is busy executing a read or write request. Bandwidth. The bits per second used by network interface. Private bytes. The number of bytes the processor has allocated that can be shared amongst other processors. These are used to measure memory leaks and usage. Connection pooling, the number of user requests that are met by pooled connections. The more requests met by connections in the pool, the better the performance will be. Memory page per second, these are the number of pages written to or read from the disk in order to resolve hard page faults. Hard page faults are when code not from the current working set is called upon from elsewhere and retrieved from a disk. Network bytes total per second. This is the rate which bytes are sent and received on the interface, including framing characters. Response time, the time from when a user enters a request until the first character of the response is received. Hits per second, the number of hits on a web server during each second of a load test. Thread counts, an application's health can be measured by the number of threads that are running and currently active. This is of course not an exhaustive list, but it just highlights the key metrics that should be used. There are a wide variety of performance testing tools in the market. The tool you choose for testing will depend on many factors such as types of protocols supported, license cost, hardware requirements, platform support, and so on. I will list the popularly used testing tools. Load Ninja. This cloud-based load testing tool empowers teams to record and instantly playback comprehensive load tests without complex dynamic correlation and run these load tests in real browsers and scale. NeoLoad is the performance testing platform designed for DevOps that seamlessly integrates into your existing continuous delivery pipeline. With this tool, teams test 10 times faster than with traditional tools to meet the new level of requirements across the full agile software development lifecycle, from component to full system-wide load tests. HP Load Runner. This is the most popular performance testing tool on the market today. This tool is capable of simulating hundreds of thousands of users, putting applications and the real-time loads to determine their behavior and the expected loads. JMeter. This is one of the leading tools used for load testing of web application servers. Performance testing is a software testing process used for testing the speed, response time, stability, reliability, scalability, and resource usage of a software application and the particular load. The main purpose of performance testing is to identify and eliminate the performance bottlenecks in the software application. There are three key attributes of performance testing. Speed response time. This is to determine whether the application responds quickly in a timely manner. Scalability. This determines the maximum user load the software application can handle. Stability. This determines if the application is stable under varying loads. Performance testing is expensive, but there is a cost-benefit trade-off. It costs to set up and do performance testing, but the benefits are in identifying where the issues that might cause the problem and ability to fix them before the software is released to the customers.